Hello? Is this thing on? Hello, hello? How goes it, everyone? Like typical. Get a couple things open and we'll get started. I wanted to mess around some more with the 3D modeling. So I will probably play with that a little bit more. I don't know if you guys can hear that or not, but if it's not loud enough, let me know. And let's see. I think the breadboard should be working too. All right. And do. Alright, so this is what I was working on. Kind of just a little case for a Raspberry Pi Zero, along with a battery and a screen. It needs a lot of work. So we need some screw holes. Need to figure out what I'm doing with the top surface, where the keys are gonna go, actual buttons to make inputs with it. Then I also need a power button. So we're gonna have to figure that out too. Let's see. Ah, okay, cool. It does work. I can't trust my code. Okie dokie. So need to put a power button. Just for context, this is how this thing is sort of going to be laid out. Is like this, and then we will have these buttons will be on top, kind of arranged like so. I know those aren't all facing the right direction, but so these will kind of be right here on top of this thing in an arrangement like this. So that's kind of the idea. And how do we do power on this sucker again? I think that's going to be this button right here. Yeah, it's going to be this one. So that's probably where our power button's going to be unless we want to wire a different one, which I think we can. I mean, having the power button up at the top wouldn't be too bad. Kind of like right up here or something. That wouldn't be bad at all. Oh, you can't even see it. Yeah, so like right up here would be where that power button's gonna go, I think. I don't know. How high up it needs to go compared to like the bottom of that, so we'll have to do a measurement. I mean, it's like right at the bottom. And we'll also need a port for we'll need ports for all these suckers, I think. So I guess we can get to like actually writing something down, huh? Let's see. Oh, hello. Helps if I have my mic on. Hello, hello. Everyone's supposed to scream, hey, your mic isn't working, but that's okay. Enjoy my horrible, drawing, is all I was saying. Oh, it should tell me. The center of that one, the 12.4. One's 41.4. How big are those? I don't even know how big those are. 11.2. $7.96, so we'll just say 8. $8.99, so that one is 9. So those are all 5 millimeters wide. And then this looks like almost exactly off to the side a little bit. By how much? I have no idea. By like not even like a half mil. Okie dokie, so I need to pull these reference faces. Actually, let's do this. Let's do the inside face of that. Can I? No. Where's my keyboard? Give me a keyboard. It's in here trying to use a ruler as a keyboard. Do, 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 do. Oh, the whole thing. The whole damn thing. Do, 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 do. Where was that? I did that just the other day. Battery cable track, let's see. How did I do that last time? Was it this thing? No. Just a visual thing. Pretty sure it was this section view. I have no idea what I'm doing. If you haven't figured that out yet, welcome. I never have any idea what I'm doing. Inspection table? No. I think? No. Not what I want. Custom tables, configuration, blah, blah, blah. Where the hecky was it? Oh, hold on. Oh, is that what it was? I'm missing that. Oof! Okay. Cool. All so that I can highlight this one stupid face. Right? Is that the one that I need? Yes. Although I could probably just, like, hide faces? I don't know. There's probably an easier way. There's always an easier way to do what I'm doing. So we do new sketch. Let me pick this face. And then what, backside? And then now I can use these as reference points. So we want a... We're just gonna do... I would just do squares for now. We'll do center point rectangles so that we can space them. This thing is going to be limited to 11.2. I didn't even measure the height. What are the... I could look up these port dimensions, but 3.22. So this sucker's going to go here, and then we're going to... Wait. Bruh. Yeah, that works. Ah! Sorry. So let's do a fixed distance between this sucker and this sucker. Give me the wall on it. Oh my gosh, it's not gonna work, is it? Make transparent. Huh. Um. What? So I can do a dimension between these freaking parallel lines, but not between this dot? What is that? Hmm. I mean, I could do that, but I don't want to. I guess let me do like a instruction line that's vertical, goes like that. And then we can do distance between those, right? What is that? That's going to be... Shit. At 12.4? And then the distance from the bottom of the thing? I have no idea. How thick is our PCB? Let's see. This is going to be... Looks to be about 3.77? 3.85? Okay. Oh, nice. Okay. This will be... There. And that's going to be that sucker. Right? Yeah, so if you've got it like that. Keychain at the top left. Okay. Next. This one's 41.4, and then that's 54. What did I say those were? 8 millimeters by... I didn't even measure the height. Alright. .95, so 3. 8 by 3. And then... Start a construction line again. Is that 41.4? Wow! I remembered it? No way. That'll be 3.88, because this guy goes... Actually, that's on the bottom of this. Huh. I guess I should figure out what the maximum height of this sucker is. I think I did that, didn't I? Already measured that. That's this thing. So 0 thickness is 18.5 millimeters, right? Yes, 18.55. Okie dokie. We'll copy those. And then let's organize some of our measurements over here, right? And this one is going to be what, 64 or something another? Wait, what? Distance between this and this? Was that 64? No, that's too much. 54. Let's see. 0. All right, let's do 0. I think, yeah, that'll be fine. Be like pi 0. I said didn't work. 0 p distance. And we make that, what is it, 3.88. Hello. What does that mean? Variable is set by multiple variable features. I don't know what I'm doing. What? Why will it not let me delete it from over here? That's so weird. Distance. It's gonna be 3.88. I don't know why that was so weird. I have a feeling we're going to be changing that one frequently, so I'm going to set it to a variable. All right. Those should be in the right spot. Should. And then what we can do is we can extrude this sketch and subtract it from the part. Let's see. And then these other ones, I guess I can do it right off the bottom because that is going to be kind of like the lowest point. I don't know. Like, how tall is it from here to there? 18.24, 18.3. And then what I measured for the total height was 18.5. So there's like a 0.2 millimeter distance between the bottom and the Type-C port. So this is going to be This is going to be sugar p distance 0.2. And that will be for this Type-C port that we're going to do. We're going to do another one. Set the size. This is going to be 9 millimeters by... Didn't even measure the height. By 3.3. 3.3. Oops, that's 3.4. 3.3. And then let's set a distance between this guy and... Hello? This guy. Whoa. Going to be sugar distance. And it's just going to be a sliver. Oops. Right. Now we need our distance from the side, which I guess is just going to be how do we want to do this? I say we base it off of this port up here. So we can do like, let's do a construction line for this guy. Right here, so we can get his vertical middle. I want to move him real quick, so that, because it's kind of like this. It's kind of offset a little bit, right? And then what we can do is we can do like a distance between these two, right? Is, I don't know, we'll just do like 0.1. This is like the offset, right? No. Let's not do that. Let's not do the middle point. Let's do this over here. It's a bit easier. Let's do that. Let's do 0.3. We'll roll with that for now. So that affixes the offset of that. And then we can do our second button thingy. Actually, I don't know, that doesn't look right. The distance between this and this. Because that's quite a bit more. Let's see, so we've got, that looks like 3.7 millimeters between these. Because we have our PCB, which is 1.45, and this other one is 1 millimeter. And we've got some washers between it. Let's see. I'm not sure the best way to... Maybe it would be wise to model the pie, or maybe I could just import a pie? I don't know. I don't know if that's even a thing. Maybe. Who knows? What is this? Go to App Store, notifications, blah, blah, blah. Whatever. We'll just do it the hard way. That's how I do everything. So if the distance to that is... Wait a minute. Maybe I do construction lines for the like the PCB thickness and everything. I don't know. Because I could do like a construction line from up here to here, and then we could divide this by, let's put a point on it, right? So it'd be like the distance between this and this is... What's that total distance? What was it? 19 point what? 18.5, so it's like what, 17.5? And then I think that's 0.5. We'll just do this, and then this distance between here and here is going to be a millimeter. Because that's that first PCB? No, it can't be at 0.5. It's going to be more than that. All right, well, let's do... So for total is going to be 18.5. Total is 18.5. .85, so this is like from here to here is 2.85. .7, and so from here to here is 8.7 millimeters, and then between these two, I think it's like a half millimeter. Oh, 1.5, 1.5. That's 1.5. So then we can just do the math, right? We've got 18.5 minus is it 2.85 minus 8.7 minus 1. No, wait, how thick was this? $1.45. That's 1.45. Those are both kind of 1.45. I'm just going to say they're both 1.45 minus 1.45. Or I guess minus 1.9, right? Or 2.9. Minus 2.9. Puts us down here. This one is 0.5 thick. No, just 1 millimeter thick, sorry. And then that leaves minus 1, gives us 3 millimeters of space down at the bottom. Maybe. And that's probably going to be fucked up and I'll have to change it. So, let's do... That's going to be 3 millimeters. And then this one is going to be... Yes, 1 millimeter. That is also 1 millimeter. This is the first PCB, this is the gap. This is second PCB, which is going to be 1.45. Oh, is the gap 1.45 too? Okay. 1.45. Gap is also 1.45. And I think that gives us like 0.5 wiggle room or 0.05 wiggle room, this little distance. That's our amount of play. Maybe. And let's see. So I guess now we just align all of our shit with this, right? So I can just do like a construction line from here to here. Like so. Oh, why this one's constrained. The other one is not. Oh well. Why is this one not constrained? What the dip? That's so confusing. Huh. Okay, so I guess now... Get rid of these. So that doesn't make sense. If this is going to be the bottom of that, because this is going to have to be coincident with that, like so. Which means that I probably need to move this up a little bit, right? That's probably where my 0.05 of shrink comes in, right? I got more than that? All right, here, let's do... Delete that. What's the distance between this and this? 2.9. Actually, let's do that the other way around, right? Because the distance between this and this should be 2.85. There we go. And then that gives us this distance. .1. How do I map? How does math work? How does measuring shit work? Oh, that's that port. It's not actually that height. Oh, it says 3.3. Okay. Let's do that one. We're gonna delete. This one's gonna be 1.4. Whoa, what did I just do? So that can move now. And we can adjust this so that that becomes like, let's set this to whatever. I'm just gonna eyeball it for now. That looks good. We can adjust these values if we need to. Actually, this probably does need to be adjusted because if I'm measuring it as precise as it is, then it's not going to fit at all. Need some wiggle room. That's okay. Let's affix this guy to this guy. Oops, no, I don't want distance. I want coincidence. There we go. No, wait, I don't want it on that one. Okay, hold on. Because this is our first board, first PCB. This is our gap. Bottom of second PCB, top of second PCB, or first PCB. So it needs to be coincident with this top line. Okay, that makes more sense. Like that. And then we can take this one, that one, coincident. And we'll do the same thing for over here. Whoa, that's why. That's why. That's funny. Okay. Cool. So that explains why that never was affixed in place. So this should be the bottom of the bottom PCB. Let's look at these measurements real quick. Bottom of the bottom PCB, top of the bottom PCB, gap, bottom of the top PCB, top of the top PCB. That's where those ports are. They're going to sit on it. Maybe I can make them sit a little bit above it. I don't know. Then we can just move this line, right? If we need to do that, we'll just increase this gap by like 1.5 or something. Or to 1.5. So that should be where those are. And then I need to get the power button, which is going to be at the top right. So that's going to be over here on this side, underneath this big boy. I don't know how I want to do the power button. I think I might do the power button as a little lever, like a lever cutout. Can I hide these? No. That's fine. I'm gonna kind of like this. All right, let's do this real quick. What do I want? No. We want to take these three, offset by, yeah, sure, 0.4. And then we are going to, let's see, we're going to trim this, right? Here we go. So then we're going to place this. The button is going to be like right here, so I want this side of it. Let's go ahead and get a oops. Actually, how big do we want this? Let's do 2 millimeters. That's going to be 2 millimeters tall. That's going to be 0.4. That'll be 0.4 as well. At least it should be. Yep. And this should also be a fixed dimension as well. Okay, this, however, let's make 2.75, so 2.75. Okay, there's our construction line for where the middle of our button is going to go. And do I want to rotate this? I don't know. Oh, sorry, music is gone. Oh, of course the code breaks when other people try to use it, and it's not just me. See, now I'm having issues with YouTube. It used to be that was perfectly fine, but now that I added Twitch support, now YouTube's crashing. Or YouTube's crashing my code, at least. How's it going, Yamaha? How do we want to position this? What did I say? I said that was, what, 3.75, roughly? Or 2.75? Oh, maybe it's not this that's going to be 2.75. I want this. Do 1 millimeter. And then this. I want to flip this around. No. I don't want to flip it around. Okay, so now this is 2.75 millimeters away from that. That's fixed. We don't really have a height fixed for it. Oh, that's because we need to make it coincident with this line. Do that with a dot. We'll just give ourselves a point right there. And make those coincident. Okay, so now that's all locked down. That's going to be our power button. So if we look at this, this is going to be our cutout. Kind of makes sense, right? And this will be kind of like a little, what you use it, flexible bit for the power button. We can start doing fancy stuff too, like filleting the edges. Like that. Like that, or whatever. Gonna leave that for later. I don't want to do that yet. Complicate things. I'll come in and fillet everything later. There we go, and then that cuts the faces. That might actually be too thick. That is too thick. We're gonna have to thin this sucker up a little bit, I think. Oops. Alright, let's see. Ooh. Lost. Yeah, how thick is this? Did I have a thickness? I don't think I had a thickness, did I? Shell distance? That's most definitely too thick. I'm trying to think of how I want to thin this up, though. I could move this whole section closer towards the edge. So, what is it? The zero cavity, this one right here. Up. Yeah, we don't really have a thickness up here for this. That kind of just threw it in here. And none of this is kind of affixed to the outer edges. So, and I don't think I have the case itself defined as width. Oh, I do, 80 by 75. Then we can take some height off the bottom if we really wanted to. I don't know if 1.2 is too thin. It's like the thickness of that, but these ports are not sticking out very much, so I'll stick with 1.2. We can change it if we need to, and we probably will. Oh, I have to come back in here and at some point adjust tons of these values. Let's look at distance between this and this. Oops. That's just going to be 10.3. So we could actually unconstrain the outer edge. This one, right? Good. See what happens when we do this. We come in here, go to our cavity sketch, and delete that, and then we do this distance between here and here. Let's just say it's 3. That's not gonna work, yeah. Wonder why that is. Okay. I guess I could just do this. Come in here and then knock this down to, like, I don't know, 70. That gives us 0.3 at the bottom, right? But if we want no, I want 70.9, right? There we go, 1.2. Math. Ugh. But see, that doesn't even need to be that thick down there. It could just be, I don't know, let's do 72. Because we don't have anything coming out of the bottom, right? No? I mean, it could have something coming out of the bottom, but... Because the thicker edge is nice for, like, a sturdier case. And then our width we can drop that down and make sure that our distance between the edge of our device, let's do that. Let's make sure that distance between, oops. Wait, what did I do? That doesn't seem right. Key thickness? I don't know. Did I mess it up? There we go. Yeah, that's 22 millimeters. 70.9. Then, let's do distance between here and here. Wait. Imaging cannot be created. But why not? Tell me. Oh, we could do that. What did that do? Nothing? Let's see. We could do like a shell thickness and then just subtract it from the inside values or something. That seems like you get complicated pretty quick. See, that's not very thick over here either. That's like 3.75, and then this is probably like 1.2 or something. Yep. 1.25. Oh, is that because it's fixed 65 wide over here? And then this is... Oops. Why is this thing affixed? Oh, is that what it is? Oh, yeah. Because I've got that coincident with the center line so that the screen stays centered with the who's it. See, that's actually outside of that. Let's see. There we go. I guess we'll just leave it at that for now. What time is it? I've got somewhere to be in a couple hours, so that's kind of not cool. We could put the keychain like more along the side right here. The keychain holder thingy. Like if we take this. Let me drag. Oh my god, please. Why are you so fucking annoying? Eh? We can move it down to like... Whoa! That's normal, right? Let's see what that looks like. Yeah, that's kind of cool. I kind of dig that. Hmm. Let's see. I guess we could do button cutouts. I mean, those are pretty simple and straightforward. I'll leave that like this for now. Certainly that will most definitely snap off. We will probably need like a, can we do a fillet or like a concave fillet? Is it chamfer? Draft? I think it's draft, right? Ooh! That's not what I wanted. Oh, let's do... Here we go. I'm gonna do the face, or the, edge. Maybe that's not a good one. I would just do that one as one operation. Whack. It's partial fillet. Yeah, good enough. Looks nice and pleasing. So we need to make a little face thingy for these. Let's do how do I want to do these? Because I was thinking kind of like, this will be like a top down of the device. And this is kind of like our screen. And then I want some buttons down here. I have like a cutout or something like that. And this will, actually that doesn't make any sense. This will be a cutout too. I don't know. That doesn't make any sense. Horrible drawing. Because I guess really what it is it's like, let's do drag. Okay. God, that pisses me off so much. We could even, we have a lot of space right over here that we can put some buttons. But I feel like this is going to occupy some of this space up here along with it. Oops. Okay, let's just say that these are going to be, I'm going to make them square. Let's make them 15 by 15 millimeters. All right. And then we are going to do what I did earlier. And gonna offset, bring this in. Like what, 0.5 or something? We'll just do 1 millimeter. 1 millimeter offset. Okay. So kind of going to be the button right there. Effectively going to be the same style of button as what I did earlier. Woo, woo, woo. Oh, you're really thinking about it, huh? And doing that change? Wowee. I think that was coincident. No, that doesn't work. I don't know why that doesn't work. Weird. That's not gonna do it, is it? Drag the damn thing. Sheesh. Yeah, that's not gonna lock it in place either. What the hecky? Oh, is that what I did? I fixed the distance between that and that? No. Free. Oh, wow, okay. I can hold control. This changes everything. Okay, how do I want to fix this and position it? I want to kind of mirror it across this center line. Symmetric. No, wait, not symmetric. Oh, I guess I can't just hold control and start dragging stuff all willy-nilly. Ooh. Freaky. Hmm. Eh? What the hell was that? Oh, okay. Oh, it's making it coincident by just dragging and dropping it onto that. That's annoying. Okay. That's okay. Because I want this to be... I don't know, we'll do 1.5. I'm just throwing numbers out there, by the way. No rhyme or reason. Oh, now that works. Okay. And then what we can do is take this doohickey, and we are going to mirror it across this line. And we're going to mirror both of these. Well, let me... Probably not. Oh, it's still trying to do mirror. I just mirrored that thing like 3 times, I guess, onto itself. Who knows? Okay, mirror that way. Then we can take this sketch and we can extrude it. This is going to be remove. Was it doing the whole thing? Oh, that's what I need to do. I'm dumb. Okay. Hold on, hold on. Back over here. Trim all of those off. There we go. Now I can extrude them and remove them. Of course, that's going to be crazy thick. I wonder if it would have been easier to start with like a solid rectangle and then done like a shell with it. And then filled in some of the space where it needs to be filled in, like kind of the inverse of what I'm doing. And that is kind of a thing, right? Oh, that goes down way too far. It's even cutting into that. Couple problems. Like, maybe I want to make like an actual space up here against like the top of that or something. Because that's where these keyboard keys are gonna go. I don't know. We'll make them go that deep for now. Let me just say 3 millimeters. It doesn't cut all the way through yet, but we can get it. We'll get it at some point. All right, I'm gonna take a break really quick. Like a 5-minute break. Refresh my drink. And I will be back in just a little bit. All right, be right back. Okie dokie, I'm back. All right. I guess the question is how am I going to get these switches if these are going to be switches that I want to use, which I don't even know if these are going to be ones that I want. Because they're kind of thick. I could do something like this with other switches. I have a bunch. Hold on. Let's see. So, and I think these are all going to be through holes. Those are sideways. Okay, let's dig through here. What are those, sideways? Those are also sideways? I mean, those might be maybes. Those are like shorter stem? Smaller footprint? No. Look at these dudes. Pop, pop. Those guys are huge. These dudes aren't bad because they're pretty thin, but they're like, they're surface mount, whereas these are through hole. They'll be a lot easier to assemble. Because if I do it on something like this, then... I mean, maybe not on that. Because that's just a breadboard. These are all... No? Wait, yes, these are all connected. I could cut them if I need to. Because this is... I don't know. Is sort of the idea. And then this can be right here. Sits on top of that. And then we can have either these guys, like so. Or some other button. I mean, you get the idea, right? And then you can pop, up, up, up. You have 4 buttons. These would be kind of nice, but I feel like they're going to be a lot harder to fit in there than something like this. Oh, these are tiny. Wow. Good lord, those are small. Those are surface mount. Of course, it's not even going to focus on it. God, those are tiny. Look at that. And everything fell apart. Yeah, so you get the picture. Buttons go like this. I'll just set them upside down. And then this goes up here. Do 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 do. Boop 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 boop. Right. That makes sense. But these are going to be a lot harder to do than these small flat boys. Go through whole typical buttons. Those are a little awkward. I think the round ones would probably be better. Oh, these are surface mount. These are through hole. Okay. So then what's what's the difference between these? You're also through hole. Or are they not different? I think one's larger than the other? No? Oh, it's got a shorter stem. This one over here has a shorter stem on it, like button stem. And this one clicks louder. I guess I'll go with the ones that click louder and have the larger stem, just that there's a surefire activation or actuation. I'm gonna set 4 of those aside. I may not even use them. I may end up using these. Oh, I guess those aren't just gonna easily go in there. I've got these weird bins in the leg that are kind of annoying, but oh well. We'll deal with those later. So I think these are probably ideal. These are going to be a lot harder to get on there and implement. I could try cutting the post off. Key switch surgery. Alright, now the question is, can the big one come off? Ow. But yes. So we can... Whoa, look at that. Doop it, doop it, doop it. Wow, okay. Is there anything in there? No. Do I have to cut that now? It's actually affecting the rebound on it. Because the trimmed out hole on it. But if I do this and I kind of widen it a little bit, it'll be fine. Hi, Lineal. Yeah, I've got one. Got a bunch of them all over the place. Yeah, it's I have a Ponagachi, an old Ponagachi, which is just a Raspberry Pi Zero. And the old case broke. It's been a minute, and I'm making a new case for it. So what I'm doing is, instead of it being a stack like this is just the battery, but instead of it being a stack like this, I'm separating it so that it is instead in a square shell, kind of like this. And this is what I've got going on so far in the the 3D model. So this is gonna be like a loop for a keychain. The Pi is gonna sit up here, and then I'm gonna have the battery down here, and then these are gonna be like little cutouts, little flexible cutouts for the buttons. So right now I'm just trying to figure out how I want to do the buttons. I've got these cool mechanical switches, but they're a little thick and unwieldy, and I don't know if getting them on this is going to be a worthwhile endeavor, or if I should just go for like one of these little micro switches. Typical micro switches, which are a lot smaller, and I could definitely get those on there instead, like in comparison. So it's a cool switch. I was checking, they've got these little posts on the bottom, these black posts, and so I was checking if I can eliminate some height by cutting those off, because they don't really even sit on this little breadboard that I have. They don't sit on the breadboard very well. So I cut those off, and then I found out that the stem of the plunger, I guess, kind of comes through. So that's what happens when you cut that off. But I might be able to, I think I can kind of trim the height of that stem, and then make these actually sit with flush to this little board, and that would actually be a lot easier. If I could do that, then I could probably use the nicer keys. So trim that off, right? Now it doesn't really come out through the thing. So I guess that could work. If you just go and you trim all the plastic everywhere, you can make it thinner. These are already like thin, slim, mechanical key switches. So yeah, something like that. And then I'll have one right here, here, and here. And then obviously that's gonna fit with the 3D model. I'll have to change the positions of these. I haven't really done accurate enough measurements. I haven't even done a test print. But eventually this is gonna be 3D printed. So that's what we got going on. Oh, what's up with your device? That sounds kind of cool. Is it ESP32 based? Is that why you're asking about ESP32s? What's a DS18B20? Is that the sensors for like a humidity or something? How do I want this? Wait, why is that one moving? Nobody said that one could move. And that sounds pretty awesome. Are you running into any troubles building it or anything like that? It sounds like it would be pretty straightforward. I feel like the difficult part would be like the not necessarily making the hardware, but mass producing it, and then also having kind of like a like the web interface infrastructure, like the web infrastructure to service it. I feel like that would probably be the more difficult parts, but I guess it depends on like your expertise, right? Maintenance and repair. What would you need to maintain and repair about it? Oh, the temperature. So are they like putting it in like really extreme conditions or something? Oh, I don't have a LinkedIn. You can uh, check me out on Blue Sky. I've got profiles there. I've got an account for this channel, and then I've got my personal account. But you should be able to find them in the description. Come on, drag. I hate this. Okay, so how do I want to do this? I want to bring this channel up. I don't know. I could just like do another specific cutout for. Could do just a specific cutout for the keys or the buttons. I guess it depends on how thick the battery is going to be. Yeah, have a good night. Good luck with your project. Sounds like a fun excursion. Let's see. Yep, definitely. As long as you enjoy doing it. think I can just do like another extrude cut or something. I don't know. Because this is going to cut it in half. So I could just have this as like open space. I don't know. Bye! Have a good night. That's like roughly 20 millimeters? What's the total thickness that I have on this thing anyway? Total thickness is 22 millimeters. So if we occupy the whole space and leave like 1 millimeter on each edge, like on the bottom and on the top. Maybe that wouldn't be too bad. And hold on, I measured these guys, right? How big were those? Or did I not? Oh, they are 15 by 15. And 8.5 in height. So these are 15 by 15. And that's about where they would be. That's... I can move them in some? I would probably want to, I think. Let's see. And bring them in 10 or 5 millimeters. Like that. Yeah, I don't know if I like that. Another thing is, these they don't really have any way of holding themselves in, with the exception of solder. And they're supposed to have like a plate that goes over the top, kind of holds them in place. And I still don't know what to do with all the inside space, like all the internal room. I guess I could assemble the keys, right? And test those out, get them working, have them wired and ready to go. Because I'm going to need to put a diode on here too, I think. Maybe not. Like if I'm doing, I think the wiring for that is I should have enough GPIO pins on this thing to not have to use diodes for the keyboard matrix. But I could do it with, what is it, 2 pins? So pin 1 and 1, pin 1 and 2, pin 2 and 1, and 2 and 2? I don't know. Kind of thinking out loud. Alright, well, I guess let me trim these guys up, since I'm going to need to do that anyway. And then I can solder them to the board. Will these be offset? I think they will. If I set them up like... Having the key... Let's see here, I'll get you guys. So having the key go this way, this little actual plunger part, I feel like would be better for the levers if they come down and press it like this. So I think that's what I'm gonna do. It's a little crooked because these are not particularly round pins, I think. Nor are they in like the exact right position. But let's go ahead and I'm gonna trim up another one of these and see how it goes right next to it. Ow. Oops. So it's be something like that. How does that compare to... Yeah, I definitely have to have them in there. So this whole board is... What is that, 43.3 millimeters, and then from here to here it's going to be like 32.5, which 15 to 15, and then an extra 10. So you may need to move the buttons in a little bit more. But I think what we can do is do that. All right, yeah, let me trim this up. Oops. Woo, 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 woo. Woo, 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 woo. Okay. And this doohickey. Ow. That one's gonna go like right there. And this one is gonna go right here. Oh, right here. No? What the heck? That's not right. What's going on? Oops. Oh, one more. There we go. So that's what it's gonna look like when they come out. Okay. But I could probably flip this over and solder it now. I don't know, this one's still got some nubbies. I want to file it down. All right, hold on. I don't even know if that's the most optimal way to do this, but whatever. I don't think you're supposed to be trimming keys anyway. There we go. That's it's pretty flush, huh? All right, let's see. I think we'll go grabby arms for this one. Is that gonna work? No? No, that's not gonna work. I wonder if I can use one of these doohickeys. Or if that's just gonna be too tight. That's gonna be too tight. Okay. Oh, nice. I like how that's keeping my camera focusing. Okay. Let's do, I think this might be adequate. And I want to bend it a little bit so it's not crooked. Okay, there we go. I need to print more of these. These are such a great print. Printed them such a long time ago. Let's see. Oops. There we go. All right. And electrically, these are all still separated too, since this is going to here. Let's see if I can shit on it. Hello? Hello? Okay. I don't know if you can see those pins, but those are still electrically separated. So I should be able to solder that, and it should be fine. It'll be good to wire. Let's get these guys going. I don't need you hands. Get out of here. This out of here. There's so much shit everywhere. I can't possibly be the only person, right? There's so much shit everywhere. Alright, get the iron heating up. A little bit more flux over there. Probably too much, honestly. Alright, and contact. Hey, what's up, Noel D-Ref? Yeah, do you like the cheese mat? It is yellow, right? I kind of like how yellow it is. Oh, yeah, I know what that's like. It's so hard to maintain a good sleep schedule sometimes. Boop, 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 boop. Also, check this out. I got these little magnetic PCB grabbers. They inch, and they've got like a nice little soft rubber grommet or whatever. But they're magnetic, and my workbench is metal. So I could just stick them anywhere, and they're gonna hold my PCB. So, which is very nice. Much better than the grabby hands. I can't stand those things. They're so annoying. They work well for certain things, but for like most stuff they're pretty frustrating. At least for me, I don't know. I imagine everybody's different. Okay, let's get this last one on there. Yeah, these are so much better for PCBs, like actual board work. Yeah, you're right. Grabby hands are probably the best for wire. Alright, let's clamp that sucker down. Oh, this thing is breaking. Oh no. Actually, you know, I might get my other clamp. This sucker is broken. I 3D printed this a long time ago, and it actually held up really well. But you can see it's end of life. EOL. I should have another little grabby. Yeah, this will work. Sorry, a pinchy, not grabby. These are highly technical terms. Hooray! Let's see. Cool. Clicky, 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 click, 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 click. Yeah. Okay, so this should be fine. I would need to wire them up to something. I don't know how I'm going to do that. But they're going to connect to one of these guys. One of the GPIO pins. I don't know what's what. I don't have my headers printed out. I need to do that. Print out my reference sheet for the Pi 0. Yeah, so I guess I'm not doing these buttons. I'll do them later if the keyboard switches suck or cause problems or something, I guess. But I've got spares in case. I don't know. Clean up a little bit. Something that I never do. The struggles of a small workbench. Okay, and I was looking for a replacement mat because the one that I had, the black one, it was smaller than the work surface, but it had these like lips on it, like these edges to keep like screws, I guess, and stuff from falling off or rolling off the mat. And it was really annoying to put stuff on the workbench and move things around with those lips in the way. I couldn't utilize the full workbench. So I spent a little bit looking for suitable work mats and honestly could not find a good suitable like workbench mat. A lot of times you'd see, like what you'd see online is like a $70 to $200 like ESD safe workbench mat. And I don't need ESD safe stuff. I'm not dealing with $1 million equipment. So if my stuff gets zapped by ESD, oh well. And all these like solder workbench mats, they all claim to be like heat resistant up to like, I don't know, 100 and something C or 200 C. And I was like, well, I solder at like 300 C or 350 C. So if those are like not heat resistant or they don't even go up to the temperatures that I'm soldering at, then maybe I could just look for something like a kitchen silicone work surface that's also heat resistant. So that's what I went with. It was really cheap. It works well. So I don't know. We'll see. I tested it with the soldering iron and it doesn't melt. So that's really all I needed. It doesn't melt with a soldering iron. Stuff doesn't stick to it. And it's easy to clean. So we'll see how it goes. Also, the orange is nice because I can see things pop off of it easily, like tiny little black wires and stuff. Those would hide themselves on the other mat. Okay, so we've got those soldered. Yeah, exactly. I'm not losing anything on the cheese. Plus, it looks like cheese. The only problem I have with it is my mouse doesn't like to slide very well, so I have this little piece of cardboard. We're janky over here on this channel. Okay, let's see. So this is our pinout. So we've got, I don't know, it's been a minute since I've taken this apart, but probably wouldn't hurt. Unless I actually do break it, it ends up hurting. Okay. Also, look at my awesome heat tube. This thing was on a keychain for like well over a year, just going at it. So I need, which pen? I could do it with, if I wanted to do without a keyboard matrix, I would need 8 pins, right? 2 pins for each, well no, I would need 4 pins and a common ground. So that's not the worst, because it's only 4 buttons. I wouldn't necessarily need to do a keyboard matrix. But if we got fancy with it, and we did do a keyboard matrix, we could just use, I think, 2 pins. Or it'd be 3. I don't know. What do we have? We've got, if our unit is going to be like this, right? Yes. Power button. Display. Keys are going to be right here. So we're going to have access to this side of buttons easier. I guess it doesn't really matter. Maybe the question is not which pins do we have access to, but how do we connect to them? Because if we solder directly right here, that's going to be problematic. Because this is pretty thin. This board down here. So this is the UPS board that delivers power. I've got the little battery for it right here. And that's going to solder on it at some point. But it's going to be oriented like this. And we're going to have access to this row of pins. And we could solder to the back side of this for our GPIO pins, but I don't know. Ooh, what if I had wire wrap? Wire wrap would be good. Could wire wrap around one of these posts, and then that way when you sandwich the connector down, it's fine. And then am I soldering directly to the back of these, or am I making like a little connector? So many questions, 0 answers. Oh, hey, no DREF. I don't know if you saw or not, but I got the breadboard code working on Twitch. So you should be able to mess with it now if you wanted to. Whether the code is going to break later or not, I don't know. It probably will, but... So I could connect these to the common ground. So like this pin could come to here and that could be a common ground. Same thing for here. This will be common ground. And then these will be like the output pins. Maybe those wire up through the center. And then come over to here. we have GPIO at 23 and 24. I think 23 and 24 are probably fine. That's going to be what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pins in, and there's a convenient ground right there, too. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Like right here at this 3. So 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. The 9 is the 1, 2, 3, 4, 5, 6, 7, 8, 9. And then so the 2 adjacent pins to that. So these 3 pins, this is our ground, this is GPIO 23 and 24. So ground, GPIO 23 and 24. No shit. I'm gonna hop off in like 15 minutes or so. But let me see, do I want to wire some stuff? I guess I could wire some stuff. Actually, I think I'm gonna solder these. Ooh, oh, that's fun. Hold on. I don't know if that sounds annoying or not, but it sounds awesome. So I could do hard wiring. I've always kind of liked the idea of using hard or solid core copper wire. And then I don't know if that's too thick. That might be too thick. I could do it over the top. Like there to there. Since this is going to be a common ground, I think that might work. Actually, I don't need this. I have a giant piece that I've already cut that I need to use. There we go. That one. Do I have another? Somewhere. There it is. Wait, is this even... This is probably too thick for this shit, isn't it? Ooh. Just perfect. Ooh. Okay. I don't think I've ever really done solid core wiring before. I usually work with stranded, so this is going to be kind of fun. I think I can do to about right here, right? And I think like that will work. I don't know. Let's see. Oh, yeah. Sort of. A little tough. There we go. Sweet. That's probably not wise. Okay. So that's in there now. And I can solder that in, and then what do we want to do for the... Oh, I've got flux all over my fingers. Bleh. The connection to the board itself. Not sure what I want to do with that or how I'm going to do that. Cleaning my fingers. Because that's probably gonna, I kind of, anytime it comes to like second component or secondary parts or whatever, I like to have connectors instead of like raw soldering. So if I'm going to be putting this into a case like such, and this is going to be right here, I don't want to have to solder a wire between these two. I want to be able to disconnect them as a module, as separate pieces or separate boards, and then be able to remove them from the build. So just something I like to keep in mind when I'm doing this. So I might just stick with something like a, ooh, you know what, like a little 90 would be kind of good. Actually, I don't know, that might be a little too thick. Let's see. So I've got these little 90s like this, but that's probably going to run into the switch itself, yeah, and that's going to add some considerable thickness to our build. I want to keep this as thin as possible, so it might be wiser to like take something like, I've got some chewed up cables, something like this. Obviously shorten it, but it's raw stranded over there, and then just have this kind of splayed out and soldered, and that'll come out to your little connector board or your little connector cable. Oops, sorry, like this. That'll come out to your connector, which can then plug into that. But these little DuPont connectors are pretty large. We could do, interesting. What else do I have? I don't have a whole lot of connectors. In fact, I don't have very many at all. I think these DuPont connectors are pretty much all I have at the moment. I do think wire wrapping would be kind of cool. I don't know if I can do that with, what is it, with this? Like if I can strip back a bunch of this and then just wire wrap it. Like if I do, like this is not the right gauge. Oops, no. These are gnarly, they'll cut anything. Let's try that again. Yeah, so say I have some wire like this, and I don't know how you're supposed to wrap it, but I'm only like slightly familiar with wire wrapping. See, I wonder if I can wire wrap it around this, that post, and that would keep it in place. Things to consider. Yeah, they're pretty nice, these Knipex. They're super sharp. They're good for cutting lots of wire. Not the best wire strippers, but... So I think that might be what I do, is end up testing some wire wrapping. I know there's tools for it. I don't have a tool to do wire wrapping. I might look those up and see how expensive they are. Because that's what I need, right? Is more tools. Yeah, so I've got to hop off. I've got a meeting to go to. But thanks for hanging out. I'll probably be back on tomorrow, maybe. We're going to do some more of this project and get this kind of ironed out, because there's a lot of software stuff that I want to do with it too. I still want it to be a Ponagachi, but the reason why I'm adding buttons to it is so that I can have some interactivity with changing the software up, making it do different things on the fly. So there'll be some coding to go along with this project. Definitely not going to have it done anytime soon, so like any of my projects. But yeah, thanks for hanging out. Like usual, if you guys want to see more of this, check out the description. Like and subscribe to the channel, and if you want, you can come hang out with us in the Discord. And yeah, that's about it. I'll see y'all later. Bye!